Hello everyone, welcome to Micro Minute. My name is Marty Jobson and today, underneath the microscope, I shall be placing some of this stuff. Dried active yeast from Allinson's in this case, although it doesn't really matter where it comes from, that's not important. So this stuff is an organism. It's an organism called Saccharomyces cerevisiae, which is the Latin name for a single-celled, an incredibly important single-celled fungus, basically. So this is related to mushrooms more than to anything else. Now, this stuff, I'll just show you on the desk camera what you've got in the pot. Looks like that. It's just lots of little kind of beads of, I'll sort of give it a poke around with my pokey stick. Okay, there it is. Just lots of little beads. And what I've done is, put that away, don't need that, let's come back to the main camera, is what I've done is I've taken a little shot, this is a little shot glass that I happened to have, and I put some yeast in it, so a little quarter teaspoon of that stuff in. I added a quarter teaspoon of sugar because it needs something to eat, because it's a living organism, and then I filled it up with warm water at about 30 degrees, and then I've just left that there, and you can see it's starting to go frothy at the top. I think it's time to go back to the camera here. Ooh, it's a bit kind of, I can't tip it down, but it's certainly beginning to froth a little bit at the top. So let's take a look underneath the microscope at what we've got. So I'll give it a bit of a stir around, give it a little bit of stir, and just take a single drop of this stuff and place it on the microscope slide like that. Whoop. I actually need to put my glasses on because otherwise I can't see what I'm doing. And then I'm going to take one of these things. This is a cover slip. You can just about see it there. Have I got a single cover slip? Yes. That goes on there like that, and then I very gently lower it down in an attempt not to get any air bubbles into it. That was a bit of a failure, got lots of air bubbles, but I'm now going to blot out any excess liquid because I want a very thin layer because these things are very, very small. So let's have a look. Is that going to be, that'll be okay. Let's have a look at this under the microscope. So I'm going to have a quick look. Oh yeah, yep, we have yeast. There it is. So let me show you what this looks like under the microscope. Here it is. Let me just change the illumination a little bit. It's all on automatic at the moment. And this is what it looks like. And one of the things I wanted to do today was I wanted to show you some of the powers of the microscope, so to speak. So this is what it looks like at times 10. So this microscope has got a variety of lenses on it, but the important ones really are these ones here, okay? These three ones here, just above the specimen. And these ones are the ones that do most of the magnification, so to speak. Okay, there's then another lens in here, immediately below the camera, or there's a lens here if you're looking at it down the side, which does the same thing. Now, the lens that we're currently looking at is only times 10 magnification, and there's approximately another times 10 up here. So we're looking at only about 100 times magnification. You can just about make out that there are little blobbies there, but there's no detail. So I can crank up the power to the next level. And I'm going to just do that because I get a better image. This is now, I'm actually using phase contrast microscopy. And now you can begin to see there are actually loads and loads of cells in here. It's thick with them, to be honest. And you can start to see, there's a little bit more detail there. You can start to see just about, if I turn the brightness, oh, I know what I need to do. I need to turn that open that a little bit. Is that good? That's good, yeah. You can just about see some detail in there, but these things are super, super, super small. So if we really want to see any detail on a yeast cell, and that's what we're looking at, individual yeast cells. So these are individual organisms, living organisms, they're only one cell. We need to go up to the next level of magnification. This level of magnification, I can never remember, what have I got there? That is 40 times, so we're looking at 400 times magnification. These things are smaller than a red blood cell, about half the size of a red blood cell, which I've shown you before. You can look at, I'll post a link in the comments in YouTube. So I'm going to go up to the highest power. Now the thing is, I don't really, in fact I've never used the highest power on one of my micro minutes before, because you just don't need it very often. Most things I look at under the microscope are small, but they're not that small. And the other reason I don't use it is because to actually use the highest power magnification, I need to use some of this stuff. This, oops, which you can see there's the Zeiss logo. They get an extra. Can't really see it, it's a bit bright in here. This stuff is called Immersion Oil. It looks like the sort of stuff you have in a sewing machine or something like that, sort of the lubricating oil for a sewing machine. And basically it's a very specially formulated oil, very sticky, gloopy stuff. And what this does is this helps the magnification, because when you go to the really high level, and this is 100 times, so I'll be looking at 1,000 times magnification, it actually hinders the optics to have a little gap of air. You don't want any air gaps in the system at all between the specimen and the lens. So the specimen is here on the slide and the lens is here, and I want to remove the air gap. So what I do is I'll put a tiny drop of this oil onto the centre of the slide where I'm looking, which is going to be there, like that. Right, bloop, there, a little drop of oil, and then I swing the lens in and I'll sort of jiggle it about a bit, and now there's a layer of oil between the two, and that actually helps us see things better. So I'm just going to check the focus and everything and make sure we've got a reasonable section to look at before I move to the slide. It's actually very thick. I was looking when I sort of set this up a little while ago, obviously, and I have and they've grown, multiplied quite rapidly. I'm hoping we can see some in the process, so to speak, but that's quite tricky. So let's have a look at this. So I'll go like that, and then I need to do that, and now suddenly we can see so much more detail on them. So these things now, so it's 100 times magnification on this end, another bit up here, so it's a really massive magnification. And a red blood cell would be kind of twice the size of one of these things. And so each one of these is a single organism, a single yeast cell. And you can begin to see now that there is actually some detail inside these cells. Oops, if I focus very carefully, you can see there's all sorts of little lumpy bumpy bits. Now the very darkest bit, can you see right in the centre there, the very darkest bit is probably the cell nucleus, so that's where the sort of the brain of the control centre is. And then there's lots of other things in there. Mitochondria, the powerhouses of the cell. And the fact that there's a lighter, you can sometimes, this one here sort of shows it, a slightly lighter area in the middle. That's because there's a cell nucleus in the sorry, not a cell nucleus, a cell a vacuole, which is just a bag full of fluids. These things, they're quite yeast is quite interesting to look at under the microscope. What I'm hoping to be able to show you, I'm just going to scooch around and see if we can see what any that are actually undergoing cell division. It's tricky. What I'm looking for is they undergo a process known as budding. So what happens is they sort of, there's one there. Focus. That one there is almost certainly budding. So that one there is at the process of creating a new little baby one. So the little one here that I'm centered on now, that is the sort of the daughter cell, and this is the mother cell. And this is an asexual process. There's no hanky-panky going on here, none of that stuff here. This is purely just one organism going bloop and turning into two organisms that are genetically identical, unless there's been some sort of mistakes in replication or something like that. Now, these creatures, these organisms do undergo sex. They do have sexual reproduction, but not at this point in their lifestyles. They've just come out of being dried, which they can survive, and there's plenty of sugar in there, so they're actively growing, and they're just going to undergo mitosis to create lots and lots of new cells. Eventually, what will happen is they will realise, oh, hang on, things aren't going so well. We need to make some spores, which will then survive a drought or a lack of food, and that's when they undergo sexual reproduction, and they form what are known as shmoos. They're kind of, the cell kind of grows as sort of a blob when it's near another cell. And there are two different sexes. They're not called male and female. They're called alpha and A and alpha. And when A meets alpha, and they love each other very much, they have babies. So anyway, that is yeast for you. And obviously the important thing about yeast is not that it kind of forms these lovely little blobbies, but actually that it poops out things. Right now, these yeast cells are pooping out two things. They're digesting the sugar. One of the things they're pooping out is carbon dioxide, which is making the froth here, which is what makes bread light and fluffy. And the other thing that they're pooping out right now is ethanol, alcohol, which is what makes all fermented drinks. So all the alcoholic drinks in the world are caused by yeast doing its thing. And why? And actually, when you make bread, you create ethanol as well. There's always both. You always get ethanol and carbon dioxide made. Both are byproducts. So some varieties of this yeast will produce more ethanol and some will produce more carbon dioxide. So it depends on the exact variety that you add as to whether you get lots of ethanol or lots of carbon dioxide and what the end product is. So whether you sort of end up with ginger beer or whether you end up with champagne, basically. So there you go. That's yeast under the microscope. Under the highest magnification that I can provide here, which is a bit of a faff because I have to use the immersion oil, but it's only thanks to Zeiss and this beautiful microscope that I can do this at all. If you want more information or want to see more of these, go to my YouTube channel. The link is here. There are now, I think we're on about, this is the 37th microminute that I have recorded, so there is hours of microscopy, and please do follow me on YouTube or follow me on Twitter. Right, that's all I've got time for. Thank you very much. I will see you again soon, hopefully. Take care. Bye-bye.